week as we've gone through each and every one of the single bootcamp sessions we've been able to do. Probably another thing I'd also love to mention would be about how we've basically been able to go through a number of topics or content around the Telos ecosystem and basically how the EVM chain works specifically. Yesterday, I managed to talk about how to set up your wallet and basically fund it with some test tokens in the test network. And today, I'm gonna go a bit more in depth in terms of how to actually write a specific smart contract and different things that maybe you may need to take note of or understand as well. Also, just as a point to note, we're having a giveaway going over this whole weekend. So Saturday, Sunday, for the top 4 teams, will be able to maybe share more about the project, the team, as well as the whole hackathon specifically. The prize is, I think, around 10 USD. So the first teams to get it, congratulations, but that's something that's going on in the community as well. Another thing I'd like to mention is the registration for the hackathon is coming up. So we'll be closing the registration on the 13th. That's on Monday. So all of the people who still are interested and want to form specific teams, go ahead, you're welcome. We have quite a number of teams so far. We've heard a bit more about the projects that are coming up. And we've also shared the link just in case you want to discuss more about what it is you're building and what you're trying to do. And maybe you need some comments from myself, Nathan, and the rest of the team at Telos and Memoi Africa as well. So without further more to do, I think I'm just gonna get right into it. So like I mentioned, for today, we're gonna be talking about how do we go about writing our first smart contract and basically testing it and interacting with it in the specific development environment. So what I'm going to do is I'm going to briefly go through showing you how to set up a project on your local machine. For me personally, I'm using VS Code and my operating system is also a Windows machine, but that shouldn't stop you from basically being able to perform the same things. So what I'm going to do is just going to share my screen briefly just as we get into it. So yeah, so if you can see my screen, this is basically my code editor, and this is what I'm going to be using just to take us through for today's session. So first things first, I'm going to create a new project repository. So how I'm going to do that is basically first, let me create a new file in my machine. So what I'm going to do is I'm going to open my terminal, then go to my PowerShell basically. So I'm already my user. So what I'm going to do is I'm going to cd into my desktop, since that's where all my folders are. Then create a new folder or directory in that sense. So I'll do, then maybe I'll name it Telos dash smart contract. So what I'm going to do is I'm going to enter this folder as well, but for now I'll just leave it as is. Actually, let me continue. So do Telos, then what contracts. Then, like I mentioned before, in case you don't have truffle installed, it's basically a simple command. So I'll just do truffle, then I'll do install, npm truffle install, then I'll do sweep global, just to make sure that it's installed globally. So for me, that won't be such an issue since I've already done that. What I'm gonna go ahead and do would be just to open this folder that I've created in my particular VS Code. So I have here Telos smart contracts. I'm gonna go ahead and open this up. Then from there, I'm just gonna operate it on the terminal here. So the first thing I want to do is to create a new project that we're gonna basically be using to interact with the Telos ecosystem and basically write a few codes here and there. So what I'm gonna do next is I'm just gonna type in truffle then init. What this is gonna do, like we mentioned yesterday, it's gonna initialize a new project that we can work with basically. So what happens is it opens up the truffle configuration file that I'll be using to interact with the Telos network, basically, as well as my wallet in case I'm to publish specific actions. What I'll do here is I'm also going to be writing our smart contracts in this specific folder, whereby we just be able to define what exactly it is we want to do. So that's basically the first thing. Then for the migrations, this is an option, but what you can do is you can basically specify the order in which you want your smart contracts to be deployed using a deployment script. So that's what this is gonna enable you to do basically. Then, like I mentioned, there's a truffle config. So since I want to use Open Zeppelin contracts, it's important for me to also set up an npm project. So I've already set up a truffle, so what I'm going to do is I'm just going to do npm, then init, then dash y. Basically just the y is just to say yes to all the questions that I may be given in terms of the package names and everything like that. So, or the project names basically. So once I do that is when you'll find that it basically creates this for me, an npm project with the same name as the folder, which is Telos smart contracts. This is the version, the main file being the truffle config.js and the likes. The reason for this is because I want to be installing the, what's it called? Open Zeppelin smart contracts, as well as any other folders that we're going to be needing for this particular session. So the next thing I'm going to go ahead and do is just install the packages for the Open Zeppelin contract. So I'll just do npm install. I'll do at Open Zeppelin /contracts. Let me confirm that spelling because sometimes I usually get it wrong. But basically, that's what we're gonna be able to use. So let me see, Open Zeppelin spelling. Yeah, I think we're good to go. Open Zeppelin. So another folder that not folder but package I'll need is a .env. So I'm gonna create an env file where you'll be keeping your specific secrets. In this case, maybe your keys for your wallet and the likes, which I think is important. So at least you're not hard coding like sensitive information within your own project as well. So once I do that, it's gonna run for a few minutes. Sorry, I think I put in the wrong. Yeah, I think I put in the wrong. Let me just change the spelling there. Hopefully now this will work. Let's see what I got wrong. I think it should be okay now. Yeah, I think we're good to go. It must have been a typo somewhere. Okay, so at least we're done with Open Zeppelin. What I'm gonna install now will now be the .env, I believe. Yeah, I think that one's good to go. Then there's one more package that we're gonna be needing that now will be able to help us interact with our, let me see, the particular wallet, or in this case, address that we're gonna be using as well. So in order to do that, the package that I'm gonna be using, usually use the wallet, but for this one I'm gonna be using the private key provider for Truffle. So let's go ahead and install that. So I'll just do npm install Truffle private key provider. So I think once that continues running, this is what's going to be able to enable us to basically use a private key to deploy the smart contracts onto the Telos EVM. Then while it's doing that, what I'm going to do is I'm going to go ahead and create a new file. Then I'll just call it .env. So the first variable that I would put in this file will now be my private key. So how I'm gonna go about getting this information is actually pretty simple. Sorry about that. Let me just go ahead and open up my project again. Let's see. So I need to open my MetaMask wallet just so that I can be able to see that info pretty clearly. So I'm gonna go ahead and open up MetaMask. Yeah, I think from there, then the next thing we'll do is I'll just click on my accounts and see. Let me see I want to view my account details per se. So it will give me the option for showing my private key. I'm not going to show it on screen as much as this is still a test account. What it's going to do is going to ask me to input my passwords. What I'm going to do is I'm going to just move this to a different screen and basically input my password there. Then I'm going to add. So now I'm going to be able to view my private key again as well. So just as I'm doing that, I'm seeing that the packages are still installing basically. So I think I'll just give it a few seconds there. I think once it's done, we'll be able to continue. And like I mentioned before, if there are any questions or comments as we go along, feel free to ask, so at least we can also see if there's any interesting thing that you may have. In terms of the vulnerabilities, you don't need to worry. This is just an example of how you can set this up. There's lots of other things that you can basically do with this. There's a huge rabbit hole in terms of the whole smart contracts development scene, but basically this is just some of the key things you may need to just know that sometimes you see vulnerabilities, but how you go about them is now comes with experience as well as maybe developing your skill set as well. So I think I'm done with my passwords. So now that I've been able to fetch my private key, basically what I'm gonna do is I'm gonna add it to my env file here that I just created. So I think with this as well, I don't want to show it on screen, but just so you know, this is how it's supposed to look. So I'll put the value of my private key here as an env. So once I've done that, I've saved it and I've been able to update that env file, is when we'll come back here again as well and just continue with the rest of the setup. I think the packages are done installing, so the next thing that I would do is to start working on this configuration file. But maybe before I do that, let me show you how you can go about creating a smart contract using Truffle, because they usually like some commands that you can use that can basically help you scaffold just a basic smart contract that you'll be now developing with. So basically, let me just do this. Or you can actually just create the file directly here as well, depending on which one is simpler as well. So what I'm going to do is I'm just trying to fetch some info that I can add here as well that we're going to be needing for this particular configuration file as well. But anyway, may as well just start from scratch. I don't see the issue. So actually before this, instead of me writing them here, let's see how we can actually compile these smart contracts, then test them out on Remix and see if they compile properly. Then we add them back to this specific folder as is. So I think just like I showed you yesterday, the first contract we're going to be making is the one for minting the NFTs. So I'll just leave it as Memoi, same was what we did yesterday, then I'll do MI. So these are the three functions that can be done within this particular space. Then basically what I'll do is I'll just copy this, then create a new smart contract file. Well, say maybe nft.soul. So I think it's okay. If I hadn't imported the OpenZeppelin files at the beginning, you'd realize that we would have been having an error at this particular section in terms of our imports not being recognized. Then another thing to take note of as a first NFT is actually, it's a good thing it's actually brought this error, because this is what I was going to mention. It's saying that we need to use Solidity version of greater than 0.8.20, but if you look at our truffle configuration file, it still specifies, I think it should be 8.17 or 8.19. Okay, let's see, 22, 21. So I think I'll just change it to 22 just to be safe. Then let's get back here. Then so I think what I'm gonna do, just to be safe, instead of getting some of these errors, is I'm gonna add it to a specific range in this particular smart contract. So I'm gonna change it to basically accept any range. So let's see what happens once you do that. I think now it's fine. So basically it says that it can be compiled with any Solidity compiler version 4.22 or higher, but it has to be less than 0.9, just to make sure we don't get that error as well. So basically we've created our first smart contract. So maybe what I'm gonna be doing is just adding some comments as I explain what exactly is happening here. Then the store. So basically this is a contract for minting. Actually, let me even rename it. This shouldn't be NFT. This should just be a token contract. Let me say ERC 20. Actually, just ERC _token.soul, just so it's easy to know what exactly it is. So basically it's an ERC 20, which, like I mentioned yesterday, basically deals with, how do I put it, normal tokens or cryptocurrency tokens that we can create and interact with as well. So this is basically what we are working on as well at the moment. Then you'll find here that there's specific extent as well. I'm going to show an example using a different smart contract about how it's important to be aware of the updates that happen, like in the OpenZeppelin folders. Sometimes you might find that these extensions, their locations usually change depending on the version maybe OpenZeppelin that you're using. And one of the key ways of or this has happened is there's a basically an import file called the reentrancy guard.sol file, which depending on which year you created your first one before, and I'm going to show you how it affects you when you're compiling, because sometimes you may get errors that don't make a lot of sense, but the reason is for that, or some functions have been discontinued or for counting the number of tokens that have been minted. However, now that counter has been depreciated and is no longer in use much. So sometimes depending on the tutorial you're following, if it's an older video, you may get some errors that maybe don't make sense to you now, but it's just an issue of the version of Solidity that you're using. So this is a contract for minting your own crypto tokens. So just like in JavaScript, if you're familiar with it, or even Java per se, when you create this contract, you have a constructor. So a constructor is basically what runs the first time this contract is now maybe called and created. And it basically says for you to create this contract and publish it on the blockchain, you need to set the address of the initial owner, who's gonna be owning this smart contract specifically. Then it's here that you already put the name and the sign as well. Then over here they also say that it's ownable in terms of based on the initial owner address that we had received. Then now these are the functions that are generated for us using the OpenZeppelin contract wizard as well. Okay, thank you, Mercy, as well. So if you have any other questions as well, I'm just viewing the chat. Feel free to shoot and ask. So that's basically where we are at this point. So I'm just adding comments in terms of what basically is happening. So here I'll basically just say that this constructor is run anytime this contract is deployed. And what you find is that you need to make sure that you basically specify the address of the initial owner. So since this is a contract that I've just set up on there's the OpenZeppelin wizard, let's test it out on Remix first, then we'll be able to work with that as well. So I don't know, I think I may have closed that particular, but I think we just go back. So OpenZeppelin wizard, I think it'll just pop up with whichever. Yeah, so here we go. Yeah, so like I mentioned before, you can basically just put in your details here. So Memoi, it'll just be exactly the same as what I put in the code editor. So I'll just click on these. Then I'll open it on Remix, just like we did the other day. Yeah, so I think we're done opening that up. So now the next thing to do would basically be, let's see, the next thing to do would basically be to just basically compile this contract. So it's 8.20, so 8.22 should work. So let me compile this. I think I already took us through how to connect our MetaMask wallet the other day. So I'm just gonna go ahead and test this out with whichever environment is available. May as well just try it with Shanghai and see how it operates. So like I mentioned before, so you see it's asking me to put the address of the initial owner, like I mentioned before I go ahead and deploy this contract. So what I'm gonna do is I'm just gonna use the same address to deploy it and see what happens basically. So once it's deployed, you'll see this information here, basically telling us more about, like for example, the fees, the block number, and the likes. Then you'll see that also the gas price that I had, or the gas I had has also gone down from 100, just to show that the fee has already been used. If I want to interact with this smart contract, you'll now be able to see all the functions that we had created being listed down here as well. So maybe I want to mint a new token and I want to mint it to a new address. What I'm gonna do is, let me select a different address here, maybe this one, then I copy this. I'll still compile it with the same address that I use, because it's the address that already owns this smart contract. So I'll say I want to mint maybe 50 tokens to this other address. Then I'll click on transact, just as an example. So basically once I'm done with that, I should be able to see information about the new, so it's basically told me the transaction mined and executed successfully, and you'll see the block hash, the block number that I'm using, and also where it's from and where it's going to, which is basically this address that I had input to this specific function. So I also have information about the gas price and everything that goes in line with that, as well as the execution cost as well. The next thing I want to do is basically see how, so all of these are functions that we had specified in the smart contract that we're now able to basically use. So that was just a simple example. So what I'm going to go ahead and do is actually try and write a smart contract that's a marketplace for listing NFTs and the associated, let me say, the associated contract for minting the NFTs that we'll now be putting or publishing in that specific marketplace in a quite a simple setup as well. Then after we test it and we see that it works, I'm going to show you how we now port or push those specific smart contracts onto our truffle project or npm project that we created and connecting it to the Telos network, then deploying it from there. Those are now the key steps that I'm looking at in terms of what we can basically achieve in the next 30 or so minutes as well. Like I said, if you have any questions or comments, feel free to interact in the chat. Basically just also just keeping in tabs with that as well. So what I'm gonna do is, let me go ahead and close this and open a new workspace basically. Okay, so the next thing I'm gonna do is just open this up. So I'm gonna basically tell you how to know more about your projects as well, in terms of how to use OpenZeppelin and things to look out for as you continue, just in case you run into a couple of errors during your development for the specific hackathon. So I'm gonna do create a new workspace basically. So let me say basic as well, then I'll say Memoi x Telos. Let me put a space in between so at least it's a bit legible. So let's see, I think it's still loading. So these are the contracts that usually come about when you set this up. So what I'm gonna do is I'm gonna go ahead and delete all of these. Then I'm gonna create a new file. Okay, since I hadn't deleted this. So I'm gonna create a new file, then name it marketplace .so. Oh, sorry, I realized I'm not sharing my screen. Sorry about that. I think it was a oversight on my end. Okay, so based on that, yeah, thank you, Nick. Yeah, I also noticed it on my own. I think I put it in the wrong screen. So what I'm gonna do, just continue from that point, is you remember the first thing we mentioned when you're coming up with the smart contract in Solidity, you need to set up the version that you're using, like so. For example, in my particular setting, you'll find that even in this smart contract that you are testing out here, you have this SPDX license identifier MIT, then the Pragma Solidity version. So I can just go ahead and copy paste that, then let you know how it's gonna be looking. So for me, I don't need this, since I don't really care much about the range, and maybe there's some functionalities that I'm using that are not available in other versions. I just come and say you can use any Solidity version that's greater than 8.17, just to be safe. The compiler uses 8.23, so at least in that sense we're not going to run into too many errors as we set this up. So I think that's okay. Then the next thing we're going to be doing is repeating the version. I'm going to do the imports. So the good thing is at least it's able to pick up the specific path that I'm going to be using. So you see it's Open Zeppelin, then I'll just do contracts as well. Then for the marketplace.so, there are 3 contracts I'm going to be using. I'm going to be using the counters, the ERC 721 contract, then the re-entrancy guard contract, and I'm going to explain why for each. At the beginning, if you mentioned, I'm going to show you how we're going to use this using the counters.sol file, and also how to do it without it, because the good thing about Remix is it checks all previous compiler versions and Open Zeppelin versions to see which one is compatible with your smart contract. But you see, sometimes when you're coding it on your own, maybe in your local environment, you may not have access to that feature. And counters, like I mentioned before, is a file that is not necessarily available in the newer releases of Open Zeppelin, because of a number of discussions that have been going on about it. But I'm just going to show you how it basically works. Then I'm going to show you how it works without it as well. So that's one of the key things to point out, maybe as we continue as well. Okay, no questions from you guys. I think we're good to continue. So the next thing I'm gonna do is basically, actually it's utils, not even contract. Contracts, utils, then counters, here it is. So I think with that, we're good with the first import. Basically, this will help us to keep track of the number of NFTs that have been sold through this particular marketplace. I'm creating the marketplace first because when you're creating the contract for the NFT, it needs a marketplace address to know where that data is gonna be interfaced with now in the marketplace as well. So the next thing I'm gonna import will now be the ERC 721 token. So contracts. When I go to token, then I should see ERC 721.so. Yep, there we go. Then the last one is now reentrancy. So reentrancy is basically a security feature that I think I'd recommend for most of you when you're coming up with your smart contracts to implement. Basically, it prevents the double execution of a particular transaction call to this smart contract before the first transaction has been completed. So if you don't have this, you'd find that people will try and execute multiple transactions before maybe the first ones are completed, to see if they can manipulate the smart contract. I've put it in very simple terms, but it's one of the security tools you need to check out and see how to play around with it. For the guys, I know the number of people who are interested in cybersecurity here, just based on the sign-ups and the people I've been able to interact with. If you want to learn more about it, there are lots of platforms like TryHackMe, which has a TryHackMe track on smart contract security, and they talk a lot about how exactly the reentrancy guard works and how to basically mitigate against it. So I'll just go ahead and import that as well. So here's another thing to point out. So I can find reentrancy guard in 2 different locations depending on the version of the, let me say, OpenZeppelin files you're looking at. So I'm gonna use the older one, which it's located in security folder under contracts, but in the new ones you'll find that it might be located in the utils folder, if I can confirm. So that's one of the key things to also point out. So in case you ever get that error, just make sure you check out where your files are located. And an example of what I'm going to do is, for my node modules, if you find my OpenZeppelin imports, then I go to let's say utils. You'll find that the reentrancy guard.sol file is found within utils, but in Remix you may find that it's gonna be found in the security folder. So I'm just gonna go ahead and show you how that works. Yeah, I think I don't know why I put it in caps. Yeah, so import at OpenZeppelin, then contracts, then security, then reentrancy guard.so. So that's basically how you set it up as well. Then maybe just to speed things up a bit, so after this, what I'm gonna do is basically create the contract. So there's a keyword for contract, then I'll call it marketplace as well, just for consistency. Then I say that is, or basically in other programming words, I say it extends the reentrancy guard file. So when I do that is reentrancy guard, then I'm gonna do that. So I think this was getting an error. I didn't put a semicolon. I think it should be good now. So after that, the next thing to do is I'm gonna say, so this contract is basically using the counters for, then I'm gonna do counters dot counter, basically us basically porting this functionality as well. So let's see what, okay, so if it's not found there, let's see what else we can do. So I think I'll just change this. Let me do 0.0. Then it's fine. Have I put any typos here? Yep, I did. So I think I'll just put this back to 1.7. It should be fine now. Then counters. And counters here again. So next thing I'm gonna do is do counters dot private counters, just to make sure that there's a variable that can't be manipulated from outside the smart contract, just to make sure it's protected as well. So NFTs sold, then I'll go to basically the same thing. I can just copy paste this, then gonna do NFT count in terms of the number of NFTs that are within this particular marketplace or smart contract as well. That's now the next thing to basically do. So let's see what it's telling us. Or in caps, my bad. So if that's in caps, this one also needs to be in caps. Yeah. I think very good. Then you're gonna do uint basically stands for unsigned integer. So the beautiful thing about this is if you specify 256, it basically allows you to decide what's the memory size that I want to assign to my particular integer variable, which is important if you're looking at data management within a smart contract. So you can see here there's 104, 112, 120, 128, all the way there. So for me, I'm just gonna use 256. So this is gonna be now with regards to the fee. So then what I'm gonna do is, since it's an EVM, I'm just gonna do 0.001. Then maybe I'll specify ETH in that sense. So this isn't an issue for Telos because at least you'll be able to translate that as well. So that's just in terms of how to go about setting it up. Oh, I'm just seeing a question here. Or is Remix IDE used specifically for deploying smart contracts? So what are you doing right now? Or why are you not coding on VS Code for now? Okay, so just as an example, what you use Remix for is because it's a really good tool for debugging, specifically your smart contracts. And if you want to deploy your smart contracts onto a specific network or testnet, you can actually do it from Remix as well. So the reason I'm using Remix is because it's an easy entry point for everyone who's not necessarily such a conversant dev. But from Remix, I'm gonna be showing you how we move these smart contracts onto our project on VS Code. I hope I've answered your question, Mark. So I'll still talk about how this is gonna be looking like in VS Code as well. Yeah, and hi Jerop, hope you're good. So I think I'll just continue from there as well. So, but anyway, if you have any other question, also feel free to ask as we continue. So the next thing I'm gonna be looking at is now. So we basically said, okay, this is the fee that you want to set. The next thing I'm gonna be talking about is the address payable. Basically, who's the owner of this particular asset in that sense. So payable, private. So just another thing to note is there are a number of data types in Solidity that you're going to be seeing me use, or even specific keywords that maybe there are lots of them, so hopefully we'll continue learning as we continue, but these are just some of the things to point out in terms of what I'm using. So I'll just do marketplace owner. Then from there I'm gonna do a mapping. So I'll just do uint, this time still 256. Then should be equals to or greater than NFT. So ID to NFT. So I think that's the first thing. So now we're going to do the specific structures that are basically associated with this particular NFT. Let's see. Okay. Identifier not found. See if we can fix that. I'm just gonna put this again. So think in time, I think that's gonna be fine. Just gonna ignore it for now. So then what I want us to do is create specific structures. We're gonna create a structure for an NFT. Think of it kind of like a model of that you'd use in any other programming language specifically. So yeah. So okay, good to see, at least we're on the same page mark. Yeah. So for example, the first structure is now this NFT that I'm specifying here. So if I go ahead and I say struct so I have to put specific details. So obviously it needs to take an address of the NFT contract that was used to mint it. So I keep putting it in caps. Address of the NFT contract. Then there's the uint 256 for the token ID. Then we have to have the address of the person who's paying, and also for the specific owner. So when I say paying in terms of like there's a seller, then there's an owner for this particular NFT, then there's a price. Then we have to say, is this a listed NFT or is it not listed within this particular marketplace? So we're gonna be basically using this to create these particular constructs. So I think I just put those variables here as we continue. So that's the first structure. So now we need to have two events that we specify in terms of things that can happen within this marketplace and to this particular structure. So there's an NFT listed onto the marketplace and an NFT being sold and being delisted, basically. So it has a new owner. It can also be listed again as well. So for these two, the fields are fairly similar again. Let me just go ahead and put them here. Okay, that's fine. So let me just click on tab just for easy visibility as well. So like I mentioned, so these are the fields that are associated with this here. So you'll find that the first event takes in the address of the contract, the token ID, the person who's selling this, and also the owner and the price. Then the ones that are sold, you're basically saying who sold it, owner as well, token ID, and the price. So they're very similar in that sense, but it's information that's key as we are interacting with this particular smart contract. So then the last thing is now the constructor, before we get into the specific functions that we'll be interacting with. So one of the key things to note is number one, sorry about that, is we need to have a constructor that runs when we are creating this marketplace. So basically, similar to how we did it in the previous example, you find that this market owner is what we put in as a field when we're deploying this smart contract. Sometimes it's best to use your own address specifically as well, just to make things a bit easier for you, maybe as we continue, because sometimes you can get confused if you're testing it out and you've used an address that you can't specifically remember. So that's the reason why we have this in this particular section as well. So I don't know, I say this, I think I defined this, unless I'd forgotten to do so. Marketplace owner, yeah, I think it's the way I've written it. So let me rename this. So market owner, I think we're good to go. Yeah. So That's the first thing. So now what we need to do is basically create the functions for how do we list an NFT onto this particular marketplace, and how are we going to also resell an NFT, and how we're going to go about buying an NFT. So since it's already a smart contract that I've been able to work on and also compile previously to this particular session, I'm just going to write down this code also just due to time, because I'm looking at the clock and I don't want to keep you guys here past or for too long. I'm just going to do this and explain what each specific function is basically doing in this particular setting. So I think the first thing that I need to do is, let me just do this again. So yeah, I think that it's good. Yeah, so we have a constructor. So the first function we had is for listing an NFT onto this particular marketplace. So you'd find that for this function to be used, it basically takes in three parameters. I need the address of the smart contract that's going to be used to mint the NFT, the token ID, as well as now the price. Then, like I said, there are two things that I've specified here in terms of requirements that need to be met for this to run. Firstly, I don't want to run this contract with a price that has been set to something that's less than 0. So that's also just to make sure that we don't have any unforeseen errors moving forward. Then also in terms of the value of the fee needs to be checked, so as to make sure that it's enough for the listing fee per se. So here's now where we specify the IRC 721 that we had imported up here, so at least we can use it to mint this specific contract. So the next part will now be in terms of the increment that we'll be setting. So this increment is basically giving us a count of the number of NFTs that have been listed, the ones that we have specified here in terms of NFT count. So each time an NFT is added, the count is increased by 1. That's the purpose of that particular function. So once we are done with that is when you'd find, okay, so you've been able to increase the count of the NFT. So now the thing is, now to create the specific NFT, we need to also set up the token ID and also set up the values on this particular call to the structure that we had made up here. So think of this like the blueprint that we use to list a new NFT, and all the information that we receive when we run this particular function for listing the NFT is added as a new instance of that particular model. So it's basically like a blueprint. So it's you're stamping the new NFTs that you basically created as well. So now that's just a rundown of the specific listing function that we have specified over here as well. So maybe as I continue, another thing to note would also be, okay, let me just check if there are any questions in the chat. Okay, so I'm guessing everyone is still good to go. Yeah, so the next function is now in terms of reselling an NFT. So in the case where you've already sold a token and someone has bought it, and this person who's bought it wants to list it again, this function basically helps you to do that as well. It takes in the same parameters as the previous one, the contract, the token ID, and the price. However, it also has the requirements for checking if the fee value is enough for this particular listing to work. Then also in terms of calling the ERC 721 in order to actually add this to this particular smart contracts data in that sense. So unlike here where you're creating a new token ID for this particular NFT, here basically you're saying where this NFT is equals to the token ID. So when you resell this NFT, it already has a token ID. So for me to basically make sure that I'm not creating any duplicates or any sorry about that, or any conflicts, I need to check if that token with ID already exists. And if it does, you'll find that now you're able to update this information to change who the seller is, who the owner is, to what is currently there, and also change the status of whether it's been listed back to true, because once it's been sold, it's automatically set to false as well. And maybe you can also change the initial price that you have for this particular NFT. So the other thing to do is to reduce the number of NFTs that have been sold, because you've already relisted a token that already exists within the particular marketplace contract as well. So that's the reason for doing that as well. Then now there's also now the function for buying the particular NFT. Similar concept, you have to have the address of the particular smart contract that was used to mint the NFT, and also you need the token ID of this particular NFT as well. So basically the first thing is checking to see, okay, if the NFT in the storage of this smart contract matches the ID that was given. Then also you are checking to see if the value of the price is enough, or if you have enough to basically enough tokens to cover the asking price per se. The next thing is now basically to set the address payable in terms of who's gonna be paying for this NFT. The other one is now in terms of the seller, to know who's gonna be receiving those particular tokens as well. Then this is the specification of now the ERC 721 that we had imported, and how we're gonna be using it to basically interface and run this particular function as well. Then now you transfer the fee to that particular market owner as well, in terms of just as much as you're selling it, there's a fee that's involved that someone needs to basically gain from per se. So like I said, since you've sold an NFT as well, the counter for the number of NFTs that has been sold also goes up. The other functions are basically supporting ones. Like this one is straightforward. It's a function for basically getting the listing fee, or what will it cost for you to list this NFT on this particular marketplace contract. Then this is now the function for listing all of the NFTs within this particular smart or marketplace smart contract as well. Okay, so just checking if there are any other questions. I think we're good to go. So now this one is now for you specifically. If you have a specific address and you have NFTs that you've listed on this marketplace, you can actually list and view all of those particular NFTs through this as well. So it basically returns them as kind of like an array. And now if you want to connect a front end to basically pass and showcase all of this information, this is now the smart contract functions that will be able to help you to do that as well. I have a front end for this whole project that I've already set up as well. So there's a complete repo that everyone will have access to, just to play around with this code as well and maybe ask more questions. Because I think interacting with it one-on-one also helps you to understand more about what's going on as well. Yeah, so cheers guys. So sorry, I think there's a lot of rain on my side, so sorry if you hear that in the background per se, but I think those are the key functions in terms of what you'll be interacting with in this specific smart contract. So what I'm gonna go ahead and do is create the second smart contract, which is now for minting the specific NFT, which is actually a pretty straightforward smart contract. It doesn't have too much going on around with it. Let me just minimize that because some of those files are also a bit confusing as well. So I'll do add a new file. Then let me see. So the project that I had set up before in my repo is basically called Craftly. So I'm also just going to name this folder or file Craftly nft.so. And I think also because of time, I think it's been about an hour as well. What I'm gonna do is I'm just basically gonna already copy paste what I have and also describe what's happening here. So similar to what I mentioned before, these are the contracts that we are importing from OpenZeppelin that we'll also be compiling and deploying as part of what we have. So like I said, still uses the ERC 721, which is the standard for the NFTs. Then there's the storage extension, then there's the counters. So if you look at this particular smart contract, we're using the counter just to also track how many NFT tokens have we actually minted as well. Then from these counters, we can also set the token IDs as private values, so at least they can't be manipulated outside of the smart contract as well. Then we'll need the address for the marketplace that we'll now be using, such that it will be each time we mint an NFT, we are minting it to a particular marketplace that already exists as well, which is actually important. That's why we deploy the marketplace contract first, then we deploy the Craftly or the NFT contract second. That's basically the thought process behind that. That's why in the constructor for this particular smart contract, we need to specify the address of the marketplace you're pointing to, because we're going to be using that a lot. And there's basically only one function that we'll be implementing using this smart contract, and it's the contract for basically minting a new NFT onto that specific marketplace. So you'll set the token ID to be incremented here as well. So you'll create a new variable that basically takes in a new token ID, which is equals to this being the current value that we have of the token ID. So what this means is, if I minted an NFT prior to this, what you'll basically find yeah, I'm seeing Nathan's comment on this as well. Yeah, sorry about that, guys. Mother Nature sometimes just decides. Yeah, so I think it's also dying down a bit. So yeah, what I was saying is, so maybe I minted an NFT yesterday, and this token value would increment maybe from 10 to 11. So now to mint another token again, it's gonna basically say the token of the current NFT that I'm minting is gonna be 11, but the one that I minted yesterday has a value of 10. So these two functions for safe mint and setting the token URI are basically functions that we import from the ERC 721 contract, basically this standard that we are using. So that's the key reason why we've set it up like that. So that's just in a nutshell what exactly we're building and interfacing with as well. Maybe another thing to mention would also be, let's go ahead and compile these smart contracts. So I'll compile the marketplace one first, and let's see how that behaves. Yeah, so I think with that one you're good to go. Then I'll go ahead and compile the Craftly NFT smart contract as well. So I think they're both compiled with no errors specifically. So I think, like I mentioned before, if you want to set up and connect to your MetaMask, you can basically do that pretty easily. So I think I'll use my second account, the Telos test. So once you connect, you'll be able to see. So it's gonna update and say 50 ETH, since I have 50 Telos tokens as well. So let's give it a second. It's already picked up the custom network as 41 over here in terms of, that's basically the chain ID for Telos testnet EVM. So let's see, unless I hope I picked the right account. Which one specifically is connected? Okay, it's updated. So basically, you'll be able to see this saying 50 ETH. Since we mentioned that, since Telos is an EVM compatible chain, or the Telos EVM specifically, you can still use it the same way to interface with Remix as well. And also, if I also use the Shanghai one, you'll be able to see it will still work the same. So I can just go ahead and deploy the smart contract as well, and we see what happens and how it behaves as well. Just a point to note, if you're using Remix, like I mentioned yesterday, you may see something like this that says infinite gas. That's just an error in terms of the functionality in the Remix IDE for calculating the gas fees. It can be a bit of a problem if you're trying to use multiple different chains sometimes, so that's why it gives this particular warning. So don't let it bother you too much. That's why I also wanted to focus on how we can interface and interact with it on now the Visual Studio Code platform as well. So what I'm just going to copy paste this address. As much as I'm deploying it using the same one, what will happen is, okay, I'm actually deploying the wrong contract. Let me deploy this one first. So let's see how it behaves. Yeah, so it's basically done. Once it deploys, like I mentioned before, you'll see all the details on the gas, transaction fees, and everything. So here I'll have a list of all of my deployed smart contracts, and what you'll be able to see are basically the functions that we can interact with for this particular smart contract. So for some of them, they need a couple of inputs. So before we play around with those, let's go ahead and deploy the NFT smart contract as well. Yes, actually can. So let's see. Telos, EVM. Okay. I think that's okay. Let me clear this. Yeah, so like I mentioned before, I'm going to show you how to do this with Remix as well as now with on Truffle as well. So like I mentioned before, the only challenge might just be the gas calculation, because I know it's a bug on Remix that's currently there. But if I go ahead and deploy, it may give me let me pick the right contract. So marketplace contract. So if I go ahead and click on deploy, it may give me a warning. So this is what I was talking about. I've done this before a number of times with Telos, but Remix has a major issue in terms of their gas with multiple chains. So that's why you may get this gas estimation error. But it's not an issue with the smart contract. It will still run on Telos. That's why I wanted to go through how to do this on Truffle as well. So now, since we basically deployed and seen that, okay, our smart contracts work pretty well, what I'm going to do is, since I want to deploy them on Telos, I'm just going to deploy them directly from my VS Code. So what I need to do first is let me download these smart contracts. Download this as well, then come here. So what I'm going to do is I'm going to move them to my contracts folder. Then I'm going to set up the environment variables for the Telos network so that we can be able to interact with them as well. So let me just open up my folders. So go to my downloads. Let me just drag and drop these two files here. So let me delete this because I don't need this anymore. So I think that's once that is done, like what's gonna happen is that if we first thing you need to do is we'll specify the particular network here. So let me just remove all the comments so it's easier to read. Then let me also go ahead and do this. So now that we're done with that, what I need to do is basically sorry about that. Now set up the configurations on my truffle. So the first thing I need to do is to import the .env library so that you can read the environment variables from my side. So what I'll do is I'll uncomment that particular part. Then I don't need this line of code. So what I'm gonna be doing is basically creating a new constant value which will now hold my private key provider that I've already imported to the project on my node modules, which we did at the beginning of the session. So I'm just going to do const, basically for constant. Then I'm going to do private key provider. Then from there I'm going to do require. Then I'm going to do truffle private key provider, because I think it's here in my node module, so let me just confirm. If I confirm it on this side, yeah, it's already here, so we're good to go with that particular package. The next one I'm going to be doing is now creating a constant for my private key. So once we're done with that, I'm just going to do process dot env. Then let me just check my env to view. So I think, yeah, I think it was in caps. I don't want to open it up, but I think it's gonna be working fine. So I'll do private key, like so. So I think that's fine. So that's the first thing that we're going to be doing. The next thing now is we need to set up the network. So as we all know, Telos has its own specific network details. So under now networks, this is where I'm going to add this. Well, basically say the Telos testnet. So you'll have it taking my private key using the provider. Then this is now the RPC I was using, but let me actually use the more common one because I was using Telos. Let me just confirm the specific details for the other testnet or RPC. So okay, so I'm gonna open this up. Let me just check these details. Let's see, Telos scan. Actually, no, let me actually do chain link instead. I think it will give me more specific info. So chainlink.org. Let's see. What is the mainnet one? I don't know if speaking the mainnet, but I think it's fine. But I've seen, just based on that, I can just use the telos.net/EVM, which I think should also be way easier to interact with as well. So I'm just going to go ahead and do this, which I think is fine. Then the network ID being 41, I think is okay. Yeah, so basically set up the network to communicate with Telos. Then we set up a private key as well as the providers and everything under the library that we'll be needing to interact with this as well. Sorry about that, Marcy. Don't worry, I think the recordings will still be available as we continue, so you can always track back and check this out as well at your own time. So that's the first thing. Then the next thing to mention will now be updating these particular smart contracts to avoid any errors that you may encounter. Remember how I mentioned that for the newer versions of basically Open Zeppelin, this function is no longer supported. So what I need to do is just change my code slightly to do the same function using the counters, but implementing it on my own, so we don't get any errors. Because if I have to show you an example, let me try and do truffle compile. You'll see I'm going to get the first error for counters, then the second one will be for the reentrancy guard. So for the reentrancy guard, it's pretty straightforward. I just need to change this to utils. Let me just confirm that on my end as well. So it's under, yeah, it's definitely under utils. I think that's okay. So we are done with the reentrancy guard. So what we need to do now is to basically rework the, what's it called? The functions that we have here that help us implement the counters. So I think the first thing I need to do is, let me just go back to Craftly, and I'm just gonna remove this import. But before I do, let me run it so you can see what I'm talking about, so at least everyone can see it visually as well. So if I do truffle compile, just give it a second, see how it goes. It's gonna give me an error to do with, okay, reentrancy guard not found, and the counters, just like I had mentioned. So I'm guessing it's still being imported in one of my files. Hope I saved it. Oh yeah, I hadn't changed this to utils yet. Let me save it, then let me clear. Then you'll see that that issue will be gone. So we'll only have issues with the counters now, just like I mentioned before. So let me go ahead and update this to show you how you can do this without the counters. So I'm just gonna omit that, then omit this particular section as well, then just update it with a couple some information as well. So if I don't want to use the counters, what I'll do is I'll set up variables that basically hold that particular value. So I'm gonna create this, well, say NFTs sold and NFTs, and the count of the number of NFTs that are actually there in this particular setting. So these are now the variables that we will be manipulating as we continue with this particular smart contract. So the next thing we're going to be doing is, let's see the other word, it's this, I'm using the counter. So here it is. So you'll see I'm doing NFT count increment here. So that's the first part where I'm going to be incrementing it. So just to confirm my value, NFT count, I'm just gonna omit this last part, the increment. Now I'm just gonna do plus plus, which will basically do the same thing. So let me look for any other instance. I think for this as well, I would remove that particular function since it was originally importing that counter smart contract as well. So sorry about that. Then so this is now for the resale for NFTs sold decrement. So for now, what we're going to be doing with that is just do minus minus, which is pretty straightforward. Let's see if there's also another instance here. So if it's an increment, I'll just change it to that. Okay, so I think everything is good to go in that sense. Yeah. Okay, I think those are all of the instances that we were using that. I can still search just to confirm. None. Okay. So with that, it's updated. So let's look at this one as well. Same thing. Just remove this. Then remove the counters. For this one as well. Just see if there are any other questions in the chat. Okay. So I'm just going to use this as minted token count. So I think what I'll do is I'll just update this whole file with the one that I already have as well. Then, so what I've done is I've replaced the counter basically with another variable that says minted token count as well. So that's what we're going to be using as the incremental or the value to know that specific count in terms of what you actually have. Then, like I mentioned before, make sure the variables are private so at least they run as expected. So I think the next thing is let's try and compile it again. Let's see if we get any errors. Oh yeah, there's a current. I think there's something I'd forgotten to change. Ah yeah, NFT count current. Okay. So let me go back here. I'll call that instance of current. Yeah, so under get listed NFTs, so let me remove this. So at least it will be able to return that specific value as is, since it's a variable. So I think that's good to go now. So let's see. Oh, okay. I think I also had another one. Actually, there are multiple instances. So there's that. So there's this as well. Let me remove this. Then let me remove this. Yeah. Okay, that is good now. Go up. Let me search for this. Okay, so I think that's fine. Okay. Yeah, so compiled successfully. So at least with that, the contracts are compiled. Let's just look at the build. So this is where you'll see all of the JSON format for all of the contracts that have been compiled as well. So if you're using setting up a front end, these JSON files become also very key because they also help you out a lot. So at least now we've been able to see that the compiler works great. So now the next thing is now to compile it onto the Telos network. So what I'll do is basically I'll migrate them. So I'll do truffle, then migrate, then network, then just to confirm the name that I gave to this particular smart network for Telos. Let's just check it out. Let's see. Okay, Telos testnet. So I think it should work fine. Let me just confirm network ID, providers. Yeah, I think we're good to go. Yeah, so yeah, so Telos. Let's see. Check if there's any question in the chat while that's running. Okay. Let's see, Telos testnet. I think it should compile fine. If there's any issues, maybe it might be the ID, but I don't expect anything. So let's see. It's just gonna compile fine. Let's see if I have an issue with my network settings. Compile successfully. Let's see how it goes with the network. Let's see. Okay. It's still taking time. Okay, let's see what it tells us. There's an issue. Let's see. Well, attempting to connect to the network at undefined. So I guess this is an issue with my specific web provider. So let me see if I can update that. Let's look at this. So basically the issue is that it's not communicating, but other than that, the contracts are compiling well. So let's see, private key, provider, let's see, network 41. Is there anything else that I'm missing? Because based on what I'm seeing, must be an issue with the version I'm using. So if I'm using Web3 core, okay, do this clear. then npm truffle at latest. I should sort it out just to make sure everything is updated. Oh, typo. So it's supposed to be npm, not nmp. So just give it a minute, then we'll go to run it again. Just wait and see, let it run. Okay, if there are any other questions that you may have, you can just drop them in the chat, just as I wait for this to finish updating, then we can go on. Then maybe while we're still at that, just a point to note, for those of you who've really set up the links to, or basically set up an invite with me, I'm just sharing the link to my calendar again. Just in case your team hasn't set up a call with me, they can be able to do so via this link as well. So I think with that, you should be able to go, you should be good to go. See if I can find it. I'm just dropping it in the WhatsApp and the Telegram chats, so at least everyone can also get access to that. Okay, I think that's done. So I'm gonna check this out. When I'm doing that, I can also just root my package.json, just ensure everything is up to speed. I think that's still taking its time. But anyway, also just as a reminder, maybe as I'm also finishing up on this, is we still have the Twitter space happening. Actually, I think it's just about to start. It hasn't started on the Memoi channel. So if you want to have a chat at Dev Banters just after we are done with this session, hearing more about experiences that devs particularly in our community are having, like listen in on Twitter and see what guys, and maybe you can also just contribute to the discussion as well. So yeah, seems updating Truffle takes a bit of time, but I think once it's done, it should be good to go. Then just checking to see if there are any questions in the chat. I don't know, Marcy, are you still with us, or are you still having issues with your network as well? So I think maybe while I'm doing that, I can just go ahead and also update the repository, make sure that everyone has access to it, and basically just take a look at it. I'm sharing it with you guys on the chat. But actually, I might as well just make a new repository now instead of having to basically having to share the other one. Since this is one we've worked on together, I might as well share this instead. So you can also be playing around with it over the weekend, just getting familiar with connecting to Telos, and also just writing your own smart contracts as well. Yeah, I think there's some progress. Hopefully it'll be done in the next few minutes. It has been slightly longer than the other ones that we've done during the week, but at least it's better to be thorough with it and at least just be up to speed with some of the nitty-gritties in terms of writing Solidity smart contracts. There's actually so much to learn, still learning myself, because there are different ways of using them that I haven't experienced just yet, but definitely always looking forward to seeing and learn something new or something more. So yeah, I think we're almost done with this. So the first thing I've done is I've updated Truffle just to make sure if there are any dependencies that are bringing issues, that's been sorted out. Then the next thing is now to update the Web3 package itself, because that was a specific one that was having some timeout issues in terms of making the specific connection to the Telos network as well. Yeah, sorry, I think we're still good. I think my YouTube was telling me that I'd been dropped off for a second there, but I think we're still good. Yeah, let's just see how things are. Yeah, I think it's still buffering. Sorry about that. I think the network went down for a bit, for a second there. Hopefully we are good now. Just drop in the chat if you can still hear me, because I don't know, I'm not sure if I'm still online at the moment, since my network is telling me that it's buffering. So just drop a thumbs up or a comment in the chat, just letting me know if you're still with me. Seems I've dropped off, not sure. Okay, I don't know, am I still on? Okay. dropped off. Oh, okay. Thank you, Emmanuel. Yeah, thank you for the feedback. I think for a second there, I thought I dropped off. But yeah, so I think it's almost done. Then we can continue. Yeah, thankfully, I think we're done with that. So the next thing I will do is that let me update the Web3 package and see. Hopefully, this is what was giving us an issue at the beginning. But other than that, I think we'd be good to go. All right, thank you, MVL. Yeah, that's good. I think they should take a significantly shorter time than the truffle setup. But I think after this, you'll be able to just run the same script and basically deploy your contract onto the Telos network pretty easily. So at least you'll be able to focus more on like the interesting projects I'm sure you're working on or thinking about at the moment as well. Looking forward to see what you'll be able to build. And I think, just like I mentioned before, both myself, the rest of the team at Memoi, and also Nathan and team at Telos Foundation have so much experience that they can be able to help you just sort out any issues or challenges that you may be having specifically. Okay, let's see how that goes. So I think after we deploy it, I think we'll be done with today's session. You'll just have access to the repository just to play with it on your own, as well as a set of instructions to see how to go about it. But other than that, definitely thank you for your time. I'm seeing Marcy in the chat is mentioning that she can't hear me. I don't know if it's an issue on my end. Yeah, it definitely seems that the rain is messing up with my network, but no worries. Hopefully it'll be good to go. Yeah, let's see. I think it's almost done. Yeah, okay, I think now we're good to go. So let's see if we can do this. Let me clear. Then let's migrate. I think from here we should be good to go. Then we can call it a day once we've been able to deploy this onto the Telos network. So I think with that, we confirm. So truffle migrate. Telos testnet. Yeah, I think we're good. So let me run that. I think it should be running. Let's see, it's compiling. I think we're good to go from here. Yeah, let's see. Let's go.